morning, everyone. In our previous lecture, we have already seen in what is the rank and what is the find of rank of correlation coefficient. Uh, in case the rank is not repeated, our next topic is tied rank. If there is a tie between two or more individual rank, the rank is divided among equal individual. If two items have fourth rank, the fourth and fifth rank is divided between them equally and is given as 4 plus 5 divided by 2. That means 4.5 rank to each of them. That means if there is a tie between fourth and fifth rank and both the students secure the same marks, for example, 90 out of 100. So we give the 4.5 rank of each of them. If three items have the same, that means what? Fourth rank each of them is given by. So there is a tie between fourth rank and there are three students got the same marks. So we give 4 plus 5 plus 6 because of tie is the fourth rank. So fourth rank, fifth rank and sixth rank. So we write 4 plus 5 plus 6 divided by 3 is equal to fifth rank. That means we give the fifth rank as a result of this. The following adjustment or correlation or correction is made in the rank correlation formula. If small m is the number of items having equal rank, then the factor 1 by 12 in the bracket m raised to the power 3 minus m bracket close is added to summation d square. If there are more than one case of this type, that means what? For example, there is a tie between fourth rank and there is a tie between 10th rank. For example, so if there are more than one case of this type, then the formula is rank of correlation is rho is equal to 1 minus 6 bracket open summation d square plus what we write 1 upon 12 m1 cube minus m1 plus 1 upon 12 m2 cube minus m2 up to so on divided by n in the bracket n square minus 1 where n is the number of ranks, total ranks. Got it? And here what is the m1 and m2? Because there are more than one cases the tied rank, so the first case we consider the m1 and second is we consider the m2. So here is the example of tied rank. Example 1 is find rank correlation coefficient. Rank correlation coefficient. We have already seen in our previous example because of rank correlation coefficient every question is depend on the rank not in marks. Got it? So here we are given in the rank x and y. So what is the rank? Rank is x is 10, 12, 18, 18, 15 and 40. And the rank of y is 12, 18, 25, 25, 50 and 25. And we find the row rank correlation coefficient. So see here carefully. Here is the 10th rank, 12th rank, 18 is a repeat. Okay, the 18th rank is repeat, 15 and 40. And in the subject of y, for example, rank of y, so here 12, 18 and 25, 25, 50 and 25. So here 25, fifth rank is repeat. 18 is 2 times and 25th is 3 times. For example, this is the rank of our GTU result. Got it? But these students are in a LG Institute. For example, this students is in LG Institute and this rank is according to our GTU result. Got it? According to GTU. So first we need rank X and rank Y. Because of this is the repeat rank. That means tide of the rank. So first we give another rank. Got it? Consider another rank. So in case of, for example, this students in our LG Institute, but his rank is 10th according to GTU results. So here, this student in LG Institute he secure first rank. Got it? So here we give the first rank 12, second rank 15, third rank. Got it? But in 18, that means the place is fourth rank and fifth rank because we have the sixth rank. Got it? So here, fourth rank and fifth rank, there is a tie between fourth rank and fifth rank. So what we do, we fourth and fifth rank SAM. So we write 4 plus 5 divided by 2. That means 9 by 2 is equal to 4.5. That means we give fourth and fifth rank, we write 4.5 and 4.5. Got it? But fourth and fifth rank is already considered. We already considered fourth and fifth rank. So next rank is what? Sixth rank. So we give 46 rank. Got it? According to this, we give the rank of Y. So here 12 is the first rank according to our LG Institute. 12 is first rank. Second rank is what? 18. Third rank is what? Third is 25th. So third, fourth and fifth rank are repeated. Got it? There is a tie between three ranks. So here the place value is 3, 4 and 5. So here we write 3, 4 and 5 rank are same. So 3 plus 4 plus 5 divided by 3 because of there is a tie between three ranks. So 3 plus 4 7 plus 5 12 divided by 3. That means what? 12 by 3 is equal to 4. So here we write according to 25. So 4 4 4. But we have already used in third, fourth and fifth rank. We have used third, fourth and fifth place value. Okay. So next rank is what? 6. So here we write 50 according to 6th rank. So now this question is our previous session, depends on our previous session. The method is same, rank X and rank Y. So first we find the D. D is equal to X minus Y. So here 1 minus 1 0, 2 minus 2 0, 4.5 minus 4 0.5, 4.5 minus 4 0.5, 3 minus 6 is equal to minus 3 and 6 minus 4 is equal to 2. Next column is D square. So 0, 0, 0, 0, 0.5 whole square 0.25, 0.5 whole square 0.25, minus 3 whole square 9 and 2 square is 4. Got it? So here the number of rank, that means here small n is equal to 6, summation D is equal to 0 and summation D square. That means what? Sum of all these terms. So summation D square is equal to 13.5. So here we write in X 4 and 5 ranks M, so is equal to 4 plus 5 divided by 2. That means what? 4.5. In Y, 3, 4 and 5th, third, fourth and fifth rank same. So we write 3 plus 4 plus 5 divided by 3. That means 12 by 3 is equal to 4. So here there are two things or items in the X series having equal values at the rank. See here, two values are equal, and in the Y series 3 values are same, 25th, 25th, 25th. So here M1 is equal to what? 2, because of two values are same. And M2 is equal to what? Because of 3, because here is 3 values are same. Then our formula is rho is equal to 1 minus 6 summation d square plus 1 by 12 m1 whole to the power 3 minus m1 plus 1 by 12 in the bracket m2 whole to the power 3 minus m2. Got it? And divided by n in the bracket n square minus 1. So this is our formula of according to tight rank. Got it? So here we put all these values. The values is what? 1 minus 6. Summation d square 13.5. So here we write 13.5 plus 1 by 12. M1 is 2. So 2 raised to the power 3 equal to 8 minus 2. The next is 1 by 12. So 3 raised to the power 3 because of M2 is equal to 3. So here 1 by 12 in the bracket 27 minus 3 because of M2 is equal to 3. And what is M2, M1 and M2? M1 is equal to here this rank is repeat, and here M2 is equal to 3 because 25th is repeat. Got it? So solve this step and we get rho is equal to 0.5429. So this is the final answer of rank correlation coefficient. Got it? So here our first third chapter is completed, and I will start our first chapter, basic probability. Got it? Okay. So, what is the probability? We have already discussed in our introductory session what is the probability. So, here introduction is probability theory is the branch of mathematics that is concerned with random or chance. Okay, we can say that the chance phenomena. It has attracted people to its study both because of its intrinsic interest and its successful applications to many areas within the physical, biological, social science, in the engineering and in the business world. Okay, the words probable and possible chance are quite familiar to us. Okay, we use these words when we are sure of the result of certain events. Got it? These words convey the sense of uncertainty of occurrence of events. So, probability is the word we use to calculate the degree of certainty of events. Got it? So there are two types of approach in the theory of probability. First is classical and second is axiomatic. So random experiment. What is a random experiment? An experiment is called a random experiment if it satisfies the following condition. The random experiment is very useful word in our basic probability. So first is it has more than one possible outcomes. Obviously, it has more than one possible outcomes, and it is not possible to predict the outcome in advance. We have not considered what is the outcomes. Okay. So next is the sample space. Okay. Sample space, that means the set of outcomes. Outcomes, that means result. The set of outcomes is called the sample space of the experiment. It is denoted by capital S. If a sample space is in 1-1 correspondence with a finite set. Okay, if a sample space is in 1-1 correspondence with a finite set, then it is called a finite sample space. Otherwise, it is known as an infinite sample space. For example, finite sample space. So, experiment of tossing a coin twice. Coin is one, a coin twice. So, what is the sample space? Sample space is head or tail, head or tail. Got it? So, we get maybe head, or first time we get head and second time is tail. First time is tail and second time head, or both the times we get tail. Got it? So here four outcomes. That means because a coin, tossing a coin twice. Okay. So this is the finite sample space. But in finite sample space, that means what? Experiment of tossing a coin until a head comes up for first time. Got it? Experiment of tossing a coin until a head comes up for first time. For example, we tossing a coin, okay, and we get head. It's okay. Second time, we tossing a coin and first tail, and again we tossing a coin, we get head. So maybe first time tail, second time tail, and we get third time head. First time tail, second time tail, third time tail, and we get head. First, second, third, fourth times we get tail, and next is head, and maybe first, second, third, fourth, fifth time we get tail, and after that head. So this type of tossing a coin, this type of experiment is the example of infinite sample space. Got it? So next is event. What is the event? Event, that means a subset of sample space is known as event. That means what? Each member is called sample point. So here the example is tossing a coin twice. So our sample space is equal to what? Outcomes is head, comma, head or tail, comma, first we get the tail and after that head, or both the times tail. So here event A, getting tail both times. So here A is equal to T. Got it? Because getting tail both the times. And event B, getting tail exactly once. Getting tail exactly once. So here the set B is what? Head or tail, comma, tail or head. So here this is the sample space and this is the events. Got it? So this is the outcomes. So here the definition, some important definition. First is the subset phi of the sample space is called impossible event, because one event is impossible. So the subset phi of a sample space is called impossible event. The second is the subset as itself of a sample space is called certain events. Okay, if subset contains only one element, it is called elementary or simple events. Next is if subset contains more than one element, it is called compound events. Next is the set contains all elements other than A is called complementary event of A. It is denoted by A dash. That means it's not included. Got it? A union of event A and B is union of set A and set B as per set theory. An intersection of event A and event B is intersection of set A and B as per set theory. So here, if A intersection B is equal to 5, events are called mutually exclusive event. That means disjoint set. This is very important. what is the mutually exclusive event? If A intersection A and B both are events, and if A intersection B is equal to phi, so this type of events are called mutually exclusive event. Okay, and the notation is A intersection B is equal to the sign of the set X such that X belongs to A and X belongs to B. Okay, so here if A union B is equal to S, that means sample space, events are called mutually exhaustive event. This is the mutually exclusive event, and this is the mutually exhaustive event. So here set notation A union B is equal to what? X such that X belongs to A or X belongs to B. That means what? In our question, if we are given in the AND word, got it? So we write A intersection B. And if we are given in the or, so we write A union B. So last point is if A intersection B is equal to phi and A union B is equal to S, that means sample space. So events are called mutually exclusive and exhaustive events. So here A intersection B is equal to phi, so events are called mutually exclusive. And if A union B is equal to sample space, events are called mutually exhaustive events. Okay, so I will continue this topic in our next session. Okay.